Hi, welcome to class. My name is Don LaFon, Professor Don, and this week in our A+ certification hardware class, we are covering Chapter 3 on the motherboard. Now, I just want to say that I gear these PowerPoint presentations to somebody that really doesn't know much about a computer. In my CTS 1131 and CTS 1133C classes, I've had students that are changing professions. I had a plumber last semester that doesn't know anything about computers. And so I can't really assume that you guys know everything about it. I can't jump into the advanced features. I can't highlight the really cool cutting edge stuff, especially since you are studying for an A+ certification that is based on Windows 7, Windows 8, 8.1, and 10. You're not studying for an A+ certification exam that's cutting edge, the brand new, just out CPUs, hardware, and software. Now, what I did was I did add some of the some information about more current CPU processors, for example, in this presentation, just because I want you to, understand that the world keeps marching on. But if it's really below your knowledge level, this presentation, please understand that there's a lot of people that this is brand new. They've never been in a computer. They've never changed out a hard drive. They've never added RAM. They've never replaced a CPU. They've never built a computer from scratch. And if you're studying from A+ for your A+ certifications, you really need to have the basis, and this course is for the basis to understand the concepts. Of course, you can always add to your knowledge. The You Certify course that is included in my college course has, it looks like 40 different little labs that let you work through these assignments. The reading in the book is useful, and then we of course have NetLab if you're taking me in person. If you're watching this class online, we do talk about virtualization a little bit that can perhaps allow you to set up virtual machines to be able to look at Windows 7, 8, and 10 in a safe environment, but it doesn't really give you the feel for what it's like to actually add a hard drive or replace RAM. You might want to actually consider building a computer from scratch, and then it doesn't have to be a cutting edge $10,000 computer. It could be a $500 computer. Today's world, you can get all of the pieces to build a computer for relatively inexpensive, as long as you're not looking for the cutting edge. Maybe it's time for an upgrade. Building your own computer would definitely help you to get ready for that A+ certification, because you'll be able to put hands-on experience with your knowledge that you're gaining in class. All right. So that's just an introduction. Today we're talking everything about the motherboard. Motherboard is basically what everything connects to inside the computer case. The actually external things connect to it too. Your printer connects to a port on the back of on the motherboard, for example. We saw those ports last week. Now we're going to actually look inside the case at what connects on the inside of a computer case. We're talking about the motherboard today. If you are with me live and you have a question, please hold those questions until the end of the presentation. I'll give you a moment to ask questions, and I'll be happy to answer those. If you are watching this as a recording and you're taking me live in the summer of 22 or any other class, then go ahead and ask your questions in the help discussion forums, and I go through those almost every day to see if anybody has any questions. If you're watching this out on YouTube, then please ask your questions in the help in the comments section below the video, and we'll help you with answering your questions. I also encourage you to add updates. So if something else is brand new, like the newest Intel motherboard is a 1120, I think. No, it's 1200. 1200. Maybe there's a newer one, and maybe you want to drop that in the comments saying, "Hey, your your video's out of date. Now we've got this, and maybe a link to where we can all learn more about it. Really, college and all of you out on YouTube, it's a learning process. And if you're in computers, it's a continuous learning process. You never are done learning about computers. If you didn't know that already, I'm sorry. I just maybe burst your bubble. But you will always be learning about computers if that's the field you want to follow for a job. All right, let me go ahead and share my screen, and we'll get started with the PowerPoint presentation. And I have to do a couple things on my end to make it work right. Open the chat room. If I ask any questions because I've forgotten a word and you're live with me, please answer in the help discussion forum. Just type in whatever the word is that I've forgotten. It happens all the time. And one more thing, I've got to minimize this window. All right. Okay, on the motherboard, chapter 3. In this presentation, we're going to talk about the soft skill, which is the benefits of active listening. We'll talk about motherboard parts, processor basics, and graphics processing units, GPUs, graphics cards, also known as graphics card. All right, soft skills. Remember, a technician really has to be more than just a nerd that knows about computers. You need to be able to talk to people. And one of the best things about talking to people is, or one of the most important things about talking to people, talking with people, is active listening. The benefits of active listening includes gathering data and symptoms quickly, building customer rapport, improving understanding of an issue for both you and the user, mutual understanding between the technician and the customer. So when you get started, the customer knows exactly what you're going to do, and you know exactly what the customer wants you to do. It's a means of positive communication between technician and customer. Focus, when you're talking to a customer, focus on the customer. Listen to what they're saying instead of yourself and what you want to believe. The customer may be more forthcoming with pertinent information if you are open and honest and willing to listen to what they have to say. I know personally from experience that the customer will, if a customer pours a glass of water on top of a computer, they're going to say they don't know what the problem is, right? So listen to them, talk to them about when they found out the problem, and then listen what the symptoms are of the problem. The computer was smoking and then stopped working. And you know, or just, hey, how come the keyboard smells like coffee, right? Anyway, so it's important to have active listening. That includes nodding when they're talking to indicate you understand what they're saying. It means repeating back what they tell you. That often will help the customer feel that you really do understand what they say. When you repeat back in your own words what they say, then you'll often get buy-in from the customer that you actually know what the problem is. If you ignore what they say and start jumping into trying to fix a problem, then they're wondering if you understood what the problem was. That's where active listening comes into play. All right. So motherboards, there are thousands of motherboards. These are just some of the current motherboards that exist. Actually, these are the boxes of some current motherboards that exist. Motherboards come every variety, whether you're talking about MSI or Asus or Gigabit. Every one of them has multiple versions of every size multiple motherboard that exists. So motherboards can be very large, like the extended ATX motherboards, or they can be very small, like a mini ITX motherboard. And on the A+ certification, you need to know what some of the details about each one of these motherboards. The least knowledge you need to know is that the ITX is smaller than the EATX, and the micro ATX is larger than the mini ITX. You need to know the order of which the motherboards are built. Now, when you're building a computer, you also need to know how much space the case that you purchase. So how are you going about, did you find a case that you want and then you got to find a motherboard that goes into the case? Or did you find a motherboard that you want and you have to buy a case that fits the motherboard? Either way works. I would say go with the motherboard first and then find a case that works with it. This is an awesome website that I'm a huge fan of, and I will share it with you. Give me a moment. Let me go find it. Okay, I found the website. It's PC Part Picker. I love this website. First of all, you can start with some pre-build, some build guides, and you can even start with some builds that are already partially complete, and then you can change things out. Or, as I did when I started building my computer, I went to the PC Builder and I started from scratch. And here on this page, what you see are the main parts of what goes in a computer. You need to pick a CPU and a cooler for the CPU and a motherboard that the CPU fits, and memory that fits on the motherboard, and storage, and a video card that fits on the motherboard, and a case that fits all of that stuff. And the coolest thing is that as you select a motherboard, it only gives you options for a CPU that fit on the motherboard. So if you have an AMD motherboard, you have only options for a CPU, AMD CPU. If you have an Intel motherboard, it only gives you options for an Intel CPU. It does not let you buy the wrong part. I actually had this experience. I absolutely wanted this radiator, pre-built radiator with fans, water cooled. I forget what they're called right now, but it's an all-in-one. It's actually, that's the answer. It's AOI, I think, AOI, all-in-one, or AO1, whatever. But I had purchased it and I wanted a specific case, and it would not let me pick my own water cooler that I had already purchased. It would not let me pick the case that I wanted. Well, I overrode it. I just took out the water cooler from the build. I picked the case that I wanted. I picked all the other parts. Everything came in, including the water cooler that I want. And sure enough, that water cooler would not physically fit in a place in the case that I would be able to use the water cooler. So it was smarter than I was. I had to return the water cooler because it would not fit in the case, or replace the case. But so anyways, don't override anything. It's pretty smart. So pick a motherboard and then pick the CPU that goes on the motherboard, or pick a CPU that you want and then pick a motherboard that fits. You decide how you want to build it. But ultimately, as you move through the process, it will allow you to. So here I just picked an AMD Ryzen. So when I go to motherboard, I only get motherboards that work with AMD chips. So I'm gonna pick, and I'm obviously just selecting up. It doesn't like that. Not gonna let it work because I need details. Details. What's wrong? AM4. This is a Ryzen 5. That should work together. I wonder why it's not working. It doesn't matter. I picked it too fast. Hang on a second. Well, I'm not going to continue to mess with this. I just want you to see it. And I know it works fantastic. I just don't know why I'm getting an alert. It's probably because I haven't done something, like I haven't identified, the case it's going to be in yet. But CPU cooler, and you pick a CPU cooler, and then you pick a memory, and you just go through the steps. Storage device, you get the idea. It's only offering me, or it should only offer me, what will actually work with the system. Now notice over on the left hand side, it's also telling me the price of what I'm randomly picking right now. Here's a case. I don't know. I don't. I wonder what um, uh, I'm not sure why it's not letting me have. It's talking about price down at the bottom, by the way. I'm still not sure why I'm having a problem with capability, but you get the idea. And I did this to the point where it only gave me a few options for the case, and I had to override it because of the CPU cooler I had. But anyways, that's PC parts picker, and I love it. It's fantastic. Apple has the same kind of thing. If you're building an Apple computer, it will help you walk through selecting all of the different parts to go into an Apple computer. I'm not an Apple guy, so that didn't really help. Now, this is what we're talking about this week. We're talking about the CPU. I'm sorry, the motherboard. The motherboard has a CPU, of course. It's right there, right? Now, I went ahead and I grabbed one that has all sorts of features on it, and I just to show you that when you're picking a motherboard, it's going to have lots and lots and lots and lots and lots of options. And you have to determine what options are most important to you. For example, having PCIe, for example, is important. Here we have two PCIe PCI Express slots, and here's three PCI slots. I don't know if there's a PCIe slot. They look like they are, but it doesn't actually say PCIe. But it's just for an example anyways. We really are only going to cover a few parts here. We're going to talk about RAM. We're going to talk about the CPU socket itself. We're going to talk about the processor that goes in the CPU socket. We're going to talk about expansion slots. This is an older motherboard. You could tell, but it's not too old. It has USB 3. You can tell by these blue slots. Processor. The number of bits processed at one time is the processor's register size, word size. Today's CPUs have register sizes of 64 or 128 bits. Now, this was the first PC, the IBM 5150. It was the world's first personal computer powered by Intel 8088 microprocessor. In 1981, I believe. And I didn't go back this far with computers. I started later in the 80s. But I found this website online. It is a slide player. I found this website that somebody created a PowerPoint presentation that actually leads you through all of the generations of microprocessors. And I thought this was a really good presentation because it tells you the first processor, and it tells you that processor was actually look, the first processor was the 4004 back in 1971. How about that? I didn't realize that. It ran at a clock speed of 108 kilohertz. A whopping 2,300 transistors and was built on 10 micron. Oh my goodness. And then came the Z80 in 1976, 5 years later. TRS-80 used to be sold by Radio Shack, I believe. And then Apple One and Apple II used an 6500. And then this is the one I showed you a picture of in 1981. IBM introduced the IBM PC, which was based on a 4.77 megahertz Intel 8088 processor. it ran MS-DOS 1. Now, I never used MS-DOS 1, thank goodness. It had 30,000 transistors. So we went from 2,300 transistors back in the 70s to 30,000 transistors at running at 4.7 megahertz in the early 80s. 16-bit registers, 8-bit external data bus. Today we're running at 32 and 64. 20-bit address bus could address up to how many bits? I don't know the answer to that. I wonder why they're asking me a question. Maybe they didn't know the answer. We're talking about something from 1981, right? And then we go on in this presentation. I am not going to play the whole thing, but I do want to show that we've had many generations of CPU processors. Right now, we are at the 11th generation of Intel processors. So this presentation, whenever they built it, doesn't even go up to all the way through to the 11th generation processor. And it seems like every 2 years we get a new generation processor. Sometimes it'll be 3 years. They talk later in the slide. We talk about Ohm's law and how everything doubles in 18 months. We'll see that in a little bit. But then they talk specifically about the different processes. You might want to look up this one and then take the time to go through each one of the generations and what was different about them, and especially the older generations, because those could be testable questions on the A+ certification, where it's asking you how many buses were on at the 3rd generation of the Intel processor or something like that. So it is real information that you may need to know. The processor, in general, it has a variety of speeds. It's measured today in gigahertz. Those early computers were in megahertz, but it's measured today in gigahertz. Hertz is a measurement of cycles per second. And 1 hertz is 1 cycle per second. A gigahertz is 1 billion cycles per second. And today's processors run at speeds above 5 gigahertz. And then I have a link here showing a current, the Intel Core i9. Oh, actually, I said 11th generation. Now we're actually at the 12th generation. This first number in the Intel chip tells you what generation you're in. My computer is an 11th generation, but there's a newer generation out now. There's a 12th generation. It claims to be the world's fastest computer processor with 5.5 gigahertz speed, right? That's 5.5 billion cycles per second. And that's what we're talking about here. This is 25 hertz. We're talking about 5.5 gigahertz cycles per second. That CPU is really working fast. That's why they get hot. And that's why they need cooling. A cycle is technically a pulse synchronized by an internal oscillator, but for our purposes, they're a basic unit that helps understand a CPU speed. When you are purchasing your CPU, you're looking at one of the things you're looking at is the speed of the processor. I have this slide here just showing over time the number of transistors. Way back in the 70s, when I showed you, we had this is in thousands, 10 to the 0. This had 2,300, right? Then 10 squared. This is a 10 times 10, 10 to the 3rd, 10 to the 4th, right? We're in billions of processors now in 2020. The number of transistors, each one of those transistors keeping track of a 1 or a 0. And then there's some other things here talking about the frequency. Now the frequency has remained the same, even though we've had additional transistors. We cover that in a little bit when we talk about the frequency of how fast it can do what it's doing. We just have been adding cores to the number to the processor itself. So instead of being a single core, dual core, quad core, 8 cores, 16 cores, heck, I don't even know what the most cores are now. Somebody can Google that and put that in the chat room if you want. What processor now has the most number of cores that's available out on the market? And then typical watts and power, how much it's using. And here we have the number of cores that we have, logical number of cores. Logical being twice the number of actual cores you have. Buses. So I was just talking about CPUs, and CPUs have, this is what they kind of look like on the inside. They have an internal bus, the electronic lines inside the CPU. They're comprised of 16, 32, 64, 128 separate lines. Now, they also have external buses that that's inside the CPU. Now, they also have external buses that connect the CPU to other things like RAM, for example. Those are external. We have the internal data bus, we have the external bus. The external bus connects the CPU to external devices. Lines are actually viewable between expansion slots on the motherboard. Some are used to send data out along the external bus to expansion slots. This is what those lines look like. If you grab a motherboard and you look at the back, I just randomly grabbed this out of the internet. I don't even know what this motherboard is. But generally, they're green in nature, although they do come in brown or tan, I guess, and copper colored. And you can see all of the lines. Each one of those is a bus, and that bus is allowing the CPU and other devices that are on the motherboard to communicate with other devices that are on the motherboard. So this is just kind of allowing you to see that. Now, the reason why you would want more lanes is the larger the bus, the more lanes, the better the performance. So if you only have one, back in the day, 8088 CPU, it had an 8-bit external bus. Now remember, you need 8 bits to have a byte, and a byte in ASCII allows you to store a single character. If you have only 8 bits, 8 buses, then you can only transfer one character at a time. If you have 16, you can transfer 2 characters. If you have 32, you can transfer 4. And today we have 64 bits that you can transfer much more information at the same time. It's also instructions. It's not just ASCII and the individual characters in ASCII, but having 64 bits allows us to perform multiple tasks in the same instruction. That's getting a little deep, but just understand more buses is better, and you'll be fine. Now, part of the ALU was, let me zoom in on this. So this part is the it's the ALU, the arithmetic, arithmetic, yes, the arithmetic logic unit. I just call it the ALU for a reason. The ALU basically runs all the calculations and comparison logic a computer needs. Now, one of the interesting things about a calculator is, the ALU, is it calculates only in addition. So basically everything's addition. So it just does it really super fast. So, and right now you're thinking, well, how does it get negative values? Well, if you add, if you want to subtract, you add a negative number, but you're still adding, right? 1 plus -1 is 0, right? If you want to divide, you add negative values multiple times. If you want to multiply, you add the value multiple times, right? You just add 10, 10 times 10 is 10 plus 10 plus 10 plus 10 plus 10, right? So that's what an ALU does. It just does math, and it does it super fast. That's how it does all the calculation with addition. The ALU connects to the control unit. The control unit coordinates activity inside the processor. The IO unit manages data entering and leaving the processor, and that's input output. And the registers in the CPU make up the high-speed storage areas for ones and zeros before the bits are processed. They're registers, so you load instructions and you load the results of instructions and the variables that are in the calculations. You load those into registers, and then you complete the calculation, and that's loaded into a register, and then that's shipped off through the IO unit and the external bus to RAM and your screen ultimately. All right. Now, pipelines. Processors have multiple pipelines or which are separate internal buses that operate simultaneously. Processes are broken down into smaller tasks, and each line helps complete the entire process faster. A 32 or 64-bit CPU can have separate paths, each of which handles 32 or 64 bits. A debate continues about whether longer pipelines improve performance. Now, what we're really talking about here, if we were going to look at it from an example of a fast food worker, you could have one person working really fast. That one person has to do everything, right? And they're going to get burned out super fast, right? They're going to get hot too, right? Or you can break it down where you have several people doing different things. So this person could toast the bun. This person could cook the burger. This person could and put it on the bun. This person could add the condiments to the burger that's already on the bun, and that speeds up the process. Or you could have multiple people going through all of the processing, multiple people doing the exact same process. That's kind of what the CPU does. It has multiple lanes, multiple pipelines that it can perform tasks. And the more pipelines you have, the more cores you have, the more the ability to do multiple things at the same time. Now, something you got to know about the CPU and memory is that there are 3 cache levels. There's level 1 cache, level 2 cache, and level 3 cache. Level 1 cache is actually integrated into the CPU. You can't really see it in this picture, but this is integrated inside of the CPU. So it is by far the fastest cache. Then you have a larger layer 2 cache that can be in the packaging, but not part of the actual CPU. Sometimes it's also called the on-die cache. And then there's a layer 3 cache, usually found in more powerful processors. They can be located in the CPU housing or out on the motherboard, but really close to the CPU. Anyways, the cache, that's short-term memory. That all of those registers I was talking about earlier, that's what we use cache for, loading and storing information. And obviously, you want that processor to be able to access information super fast, access those registers super fast. So you put it right in the processor for level 1 cache. The more level 1 cache you have, the faster your computer can work. And that's true with level 2 and level 3 as well. And it's speed inside the CPU. The registers are loaded in level 1 and level 2 cache, and they are the fastest. Level 1 being the fastest. Level 3 is outside of the motherboard or in the CPU housing, not quite as fast, but faster than RAM. RAM is on the motherboard. It's not as fast as level cache. The cache layer, well, even layer 3 cache, but it's faster than disk storage, right? Your hard drives and even your M2 drives, your SSDs are slower than RAM, and then your hard drive, that platter that spins, it's really slow. And here you can see an example of what we're talking about with an analogy is having a glass of lemonade. You know right away you are able to Drink it immediately. It's ready to go. It's refreshing. You can have it right now. Not a lot of it, but it's good. A pitcher of lemonade, you know it's coming. It's going to take a little bit to pour that pitcher of lemonade into a glass, but it's still going to be refreshing. You just got to wait another moment or two. And it can store more lemonade too, because it's RAM can store more RAM. You have more RAM on your computer. Remember, I have 128 gig of RAM. Your cache is very small compared to that. Then that hard drive, that's really slow. That's like saying you want lemonade and having to go to the freezer, getting out frozen lemonade, defrosting it, making the lemonade, putting it in the pitcher, and then finally putting it in the glass. So a hard drive is by far the slowest when we're talking about storing data and getting the data into the processor. That's why when I talked last week about your page file, when you run out of RAM, it stores the data on your hard drive. Let's say you're loading 5 programs and only 4 can load in RAM. When you go to load that 5th program, one of the 4 programs that's running has to go and be stored out on the hard drive. When the computer needs that 5th program, the first one that hasn't been used in a little while and it was stored in the page file out on the hard drive, then it has to bring in that information, and it's really a slow process. And then it has to take one of the 4 that are currently in RAM and it has to put it back on the hard drive. That's why when I'm buying RAM, first of all, it's a money thing. You can only buy RAM is expensive. The bigger the chips are, the more expensive they're going to be. So you have to decide how much RAM you want. I wanted 128 gig of RAM. Actually, I think my current system only has 64. Let me take a peek here, system. What do I got? Do I have 120? Yeah, I have 128 gig of RAM. I actually had 128 gig of RAM in my previous build, but it was in 4 sticks, and I'm sorry, 8 sticks. The X99 motherboard had 8 sticks of RAM. All newer computers have only 4 locations, so I either had to give up 4 gig of RAM. 4 sticks of RAM, half my RAM, or I had to buy new RAM. I opted for the new RAM, which cost some money. So, anyways, more RAM. I never run out of location. My computer never has to page with 128 gig of RAM. It just doesn't need it. Multi-core processors. So I mentioned how a processor could be a dual core, quad core earlier. A dual core processor combines 2 CPUs in a single unit. Sometimes it's called a die, a single die. Most Intel and AMD have quad core CPU technologies. That's 2 dual core CPUs installed in the same motherboard and 2 dual core CPUs installed in a single socket. Or more recent models have 4 cores on a single unit. Actually, that's old school. Today, we're really talking about 6 cores, 8 cores. I think mine has 6. What? Did nobody answer? Nobody took the time to look up that question. So now I have to go look it up myself. Thank you, guys. Appreciate it. Hold on a second. Help me out, all right? So here, for example, I pointed out that the newest Intel CPU is a 12900, and it has 16 cores. So the newest processor has 8 performance cores and 8 efficiency cores for a total of 16 cores. Now, I'm not going to get into details on what that means, other than the fact that it can do a lot of things at the same time. Now, the program has to be written to use all of those cores for it to work properly. But let's talk about, I have this great video that I found that explains cores and hyperthreading. Let's go ahead and watch that video now.
Intel has designed several processor technologies that enable parallel processing when running multi-threaded applications or multiple applications simultaneously. The first, Intel hyperthreading technology, enables two threads to be processed in a single processor core, allowing partially parallel execution, whereas traditional single-threaded processors could only process one thread at a time. Next was the dual-core Intel processor, today's best choice for notebooks, which enabled two threads to be fully processed in their own processor cores for truly parallel execution. There are also quad-core Intel processors, which take parallel processing on desktop computers another leap forward, allowing four threads to be processed in parallel. The latest Intel multi-core processors include Intel hyperthreading technology within each processor core, doubling the number of threads that can be processed at the same time. These advanced Intel processors are the preferred processor for desktop users running multiple demanding applications simultaneously, or for running today's multi-threaded digital media applications and gaming titles.
Yep. So I just want to pause it here to show a moment ago I told you that the 16 core actually has 32 lanes, right? Because you have hyperthreading that allows one lane to have two threads that are feeding it. So 16 cores is really 32 lanes because of hyperthreading. And in this case, the 4-core that they mentioned, or 8-core has 16 lanes, 16-core has 32 lanes of allowing you to do lots of stuff. So asset streaming, terrain generation, 3D rendering, physics effect, video encoding, right? If you're working virus scanning, all at the same time, because it's able to do that. Now, this video is several years old, but it's the perfect video. This was actually released in 2015. So, but it absolutely gives you an idea what hyperthreading is, the ability to have multiple lanes feeding a processor at the same time, and multiple cores on the same die, when you install a CPU, and I have a video coming in a little bit, but when you install a CPU on a motherboard, you don't have 16 CPUs. You have one CPU, and on the CPU is 16 cores. Hopefully that works for you. All right, let's close that. I like that video. Make sure to give it a thumbs up if you go look at that video again. And let's keep going with the presentation. Now, CPUs run hot, and on the CPU, we'll see the installation in a couple of slides. But on the CPU, having all that information through the CPU can have your CPU running extremely hot. It's not unusual for a computer to run at 50 Celsius, 50 degrees Celsius. Alexa, how many Fahrenheit is 50 degrees Celsius?
50 degrees Celsius is 122 degrees Fahrenheit.
So it's not unusual for a CPU to be running 50 degrees Celsius or 122 degrees Fahrenheit. So we need to cool that thing down. And we do it with heat sinks like this device, or a fan, simple fan. That's silly to have this fan displayed, but if you put the fan on the heatsink, now you have air being blown through the heatsink. I think that's why they put that fan there. And then liquid cooling. I have a liquid cooled computer myself with soft tubing. I've done it with soft tubing and hard tubing, and liquid actually passes over the external copper of the CPU, carrying away the heat from the CPU. That's the same thing that these copper pipes do. And you can also have passive cooling, just the heatsink itself, but you're not going to be doing some you're not going to do a passive cooling with just a heatsink on something that's heavy duty processing, because it'll get too hot. Now, I love this guy. This is Linus Tech Tips, and I love him. He's a comedian. That's what makes learning fun. with him, and he's going to talk about, and he's going to apply the thermal paste to a CPU, and he is going to put the fan on top of it, kind of just showing you how to apply a CPU cooling fan.
Is that a camera? Get out of here. When choosing a thermal compound, you want to find something with low thermal resistance, that is, heat easily passes through it, something non-conductive and non-capacitive so you don't short out anything on your motherboard, and last but not least, something that doesn't dry out over time so that you don't lose performance a couple of years down the road when your system's still running and your thermal compound's still in there. We'll be using IC Diamond. This is my personal favorite thermal paste. Before you actually start a thermal compound swap, I would definitely recommend checking your temperatures, because that way you'll be able to more easily diagnose if anything went wrong during the installation procedure. First step is to remove your existing heatsink, revealing the old thermal compound underneath. You'll need isopropyl alcohol, so you want to wet that onto a nice soft piece of, I use Charmin because it's awesome, and then you want to clean the surface of the CPU as well as the bottom of the heatsink. Now you'll notice that I'm not actually able to get it completely clean on the first go. This is because my wipe is now too dirty to clean anything. So I'm going to find a clean spot, put on some more alcohol, and do another round with the isopropyl, trying to remove the residue that was left from the first time of cleaning it. So here we see our first pass and our second pass. For the third pass, I usually just use the toilet paper without putting any additional alcohol on it, because we're trying to remove the little bits that are left behind, not leave any more, which is easier when they're wet. And then I usually finish off, and you're welcome to use something else, with just a quick pass with my sleeve or a micropad to remove any remaining residue that might be left behind by toilet paper, because those little bits can cause cooling problems. And now you can see the surfaces are clean and ready to apply our new thermal compound. Back when CPUs didn't have integrated heat spreaders, we used to spread the thermal compound out across the die or the core in order to make sure that it covered the entire thing. Now that we've put so much mounting pressure onto our heat spreaders, we can just put either a P-shaped blob in the middle or a rice grain shaped line in the middle, and we can rely on the mounting pressure of the heatsink to actually spread the thermal compound. So these are known as the P and the line method. I personally find the line method has the best consistency for me, but everyone has a different experience and it varies depending on the thermal compound. The one thing to be aware of with the P and the line method is that if you have a bigger CPU, you're going to want to apply a bigger line of thermal compound or a bigger P in the middle. This is a 2011 CPU, whereas the one down here is an 1155 CPU. Now that we have a fresh application of thermal compound and two nice, shiny, clean surfaces to put together, we should be able to observe temperature improvements of anywhere from 3 to 5 degrees Celsius over the stock thermal compound when using an appropriate high-performance thermal compound. Whoa! Hey guys, thanks for watching this episode of As Fast as Possible on Tech Quickie. If you enjoyed it, make sure you subscribe, and also don't forget to hit that like button. It helps us out a lot. Share this video with anyone you think might benefit from it, and if you have any ideas for future episodes of Fast as Possible, click the link in the description of the video and leave us a suggestion. We will make sure to monitor it, and hopefully you'll see your idea soon. See you guys again next time.
So I love Linus Tech Tips because he is a funny guy, and I have been watching his videos for more than 10 years. He's become a big corporation now, but he's just as funny and just as interesting. So I encourage you to look for him out on YouTube and to follow him. He has everything from simple tasks like what he just did to much more advanced tasks like taking apart a GPU and putting thermal pads on, replacing the thermal pads on a GPU, and much more complex than that. Anyways, so that gives you an idea how to apply cooling between a heatsink and the CPU itself. And then on top of that, he had the fan that was also to blow the air through the heatsink. By the way, I believe that was a standard stock CPU fan and heatsink that came with an Intel chip. And the newer releases of AMD, I didn't get a CPU fan and heatsink. So make sure when you're buying your CPU, your newer CPU, find out if it has a heatsink and fan. You probably want to upgrade it anyways, depending on the use of the computer. Now, Linus, during the presentation, mentioned that a specific sockets, and he had an 1156, I think, might have been 1155. But what's important to know about this is you need to know that the layout of the socket fits specific Intel chips. And you need to know that you can't just willy-nilly go buy a 2011 LGA motherboard and get a 1156 Intel i7. It won't work. They have to match. That was where that PC part picker comes into play, allowing you to pick the processor you can afford, maybe the newest generation, the 10th, 11th generation, 10th generation, but then make sure you get a motherboard that matches that. Okay, and then it shows the different generations of on this table, the different generations of Intel chips, the LGA chips, and AMD chips, and it's an older table. LGA is actually Intel is the LGA 1200 is the newest Intel microprocessor compatible socket for the 10th generation, and Rocket Lake 11th generation, but it doesn't actually say the 12th generation there. So LGA 1200 is designed as a replacement for the LGA 1151, but it doesn't say anything about the 12th generation. So I would have to check if you're going to jump out there and buy the 12th generation CPU. Check what socket it fits. You guys could look that up for me in the class if you'd like to help. What does the Intel 12th generation CPU, what socket is it? And I also have the newest AMD socket AM5. It's actually not out yet. It's supposed to debut in the second half of this year, 2022. I went looking for it and I didn't find it, and I'm making this presentation in June of 2022, and it's not released yet. It will. So good. Looks like you need an LGA 1700. Thank you, guys. LGA 1700 for the Intel 12th generation. So like I mentioned, a new CPU, a new socket. So you have to make sure you match those up, which of course is somewhat challenging, because that means if you have a motherboard and you have a perfectly good motherboard with perfectly good running RAM, and you want to upgrade your CPU to the newest CPU, well, guess what? You need to buy a new motherboard to match that new CPU. And you might need to buy new RAM that fits into the new motherboard to match that new CPU. So it isn't just the $1,000 for the new cutting edge CPU. It's also a new $400 motherboard and $300, $400 worth of RAM. You have to, it all comes in a package. Of course, it all has to be compatible. So processor installation. So we talked about a processor. We saw how to put the fan on it. But how do you actually install it? Well, obviously, you turn off the computer and remove the power. Use the proper anti-static handling procedures to make sure you don't give it any little electric shock from static. That's especially true anywhere in the country or the world where you find yourself walking over to your spouse, girlfriend, boyfriend, and reaching over to hug them, and you give them a little zap and shock them. If that happens where you live, you don't want to be showing your CPU the same kind of love. Okay, so you want to release the shock using a I don't have a picture of it, but a anti-static wristband, and then grounding yourself to the ground before you touch anything, and then release the CPU retention plate. Insert the CPU into the socket, and remember that it only inserts one way. Let me show that, and that pin, this pin right here, that's the key. Let me show you this video. He does a nice job showing you how to install the video. So this is Jay Syntax, and he created this short video to show just how easy it can be, but also with the concerns.
Installing an Intel CPU into the LGA 1200 socket is very easy, but you need to make sure you take these precautions. The first thing you'll notice on your motherboard is the protective plate, and this plate is very essential. Don't throw it away if you ever want to RMA your motherboard, because it protects the delicate pins that connect to the CPU. First, use the lever and open it while leaving the bracket on, and then insert the CPU chip, aligning the two notches on the side and the triangle on the bottom left corner, as you can see here. Your motherboard should have a triangle in the bottom left corner that you should align. The CPU chip should fall right into the socket without any pressure. As you lock the CPU chip into place, you'll hear all these kind of pins bending. It's very cringy, but don't worry, that's totally normal. And then pop, the CPU bracket will satisfyingly pop out, and that's all there is to it. And then you can carry on installing other parts onto the motherboard. If this video helped you in any way, please don't forget to like and subscribe for more tech content. See you in the next video.
So I thought that was quick and easy. Shows you just how fast. I promise you, if you've never done a CPU, install a CPU on a motherboard, it will take you longer than 1 minute and 53 seconds, and that's what his video was. So really easy process, but you need to make sure you have it lined up right. Do not, under any circumstance, touch the pins on the motherboard or the CPU, depending on what variety you have. Do not bend those pins. You have to be super careful. They bend super easy. In fact, there's the Linus Tech Tip actually has a video on how to re-straighten the pins that have been bent on a CPU, and I've tried in the past. I unintentionally, as I was picking up the CPU, I dropped the CPU onto the pins, and it actually bent the pins on the motherboard, forcing me to buy a new CPU, a new motherboard. He actually goes through trying to fix the pins, straighten them out. You want to avoid that at all circumstances, okay? But be very careful not to bend the pins. Let's keep going. GPUs. So I mentioned at some point in this program that I have several RTX 3090 video cards that are mining for me. An RTX 3090 at the time of recording this video is the fastest video card that you can get. It's definitely overkill for gaming or making YouTube videos for my channel, but I do a little mining with it, and I wanted to learn more about it, so I went ahead and purchased one of those. Now there's hundreds of varieties of GPUs, what you can ranging from $25 for a basic one to $3,000 for the cutting edge, possibly. Not MSRP, but we just went through some of you may know, we just went through a GPU shortage, and the GPU prices were incredibly high. The reason why you want a GPU is because you take the processing requirement off of the CPU. The GPU provides better video card performance. It contains hundreds of smaller core processors. It's a general purpose, meaning that it can also be used for other purposes that are not directly related to graphics. That's my example of mining with it. And a computer system can have multiple GPUs. Mine actually has two 3090 GPUs in it. And again, overkill for gaming, but it works for mining. What it does is, instead of having the CPU do the processing of the video, the CPU can handle all of the other stuff handling instructions and arithmetic calculations, while the GPU handles just the video. GPUs are awesome when it comes to mathematical operations. That's what they do. That's why they're great at mining cryptocurrency, is because it's just calculating a mathematical calculation over and over and over again, and finding a solution. So you want a GPU on your computer. Some motherboards come with integrated GPUs in the motherboard, and you'll know they have integrated GPUs because they will have a HDMI port or a DVI port right on the motherboard, and it can go right out to your monitor right without a video card. But you sort of want to avoid those because it puts more pressure on your CPU. You definitely want to have a GPU that handles all the graphics and let your CPU just handle all of the rest of the processing that a computer does. Virtual technology. Now, we get into virtualization later in the course, but what they want to talk about here is the fact that the CPU that you purchase has to be capable of virtualization. The motherboard you have has to be capable of virtualization. I have a short video to show you the concept of virtualization, but it's really just to get you a little warm up for when we cover this more in depth later in the course. But let's go ahead, and I think it's actually in the software course, not the hardware course. But let's just talk briefly about spend 2 minutes on virtualization, what it is and what it can do for you.
What is virtualization? That's a great question, given that we use virtualization every day when we access the cloud and cloud services. Today's computers have tons of processing power, including super fast CPU speeds, fast RAM that's inexpensive, and tons of storage capacity. But is that computing power being used efficiently? Unfortunately, the answer is no when the hardware and processing power is underutilized and the electricity is wasted. Virtualization helps solve the problem of underutilized resources by creating a virtualization layer between the hardware components and the user. This enables the creation of virtual machines, which are virtual computers that can run in multiple on a single set of hardware. The virtualization layer creates virtual hardware components for the virtual machine, also called the VM. In this image, you can see that the virtual machine or virtual computer needs all of the same components that a regular computer does. It needs storage. It needs access to a keyboard. It needs network interface cards or NICs. It needs processing, and it needs RAM. Virtualization takes those physical resources and turns them into virtual resources for the virtual machine. Many virtual machines can be created on a single host computer. In this image, the computer is running two virtual machines, VM1, which is running the Windows operating system, and VM2, which is running the Ubuntu Linux operating system. These virtual machines are on top of the virtualization layer being managed by VMware Workstation. There are lots of benefits to virtualization. Increased efficiency and multitasking because you can run multiple computers. Instead of just a single computer running on your computer hardware, you can run multiple operating systems or multiple computers on a single set of hardware. It also increases manageability or the ability to move, copy, and isolate virtual machines. Sustainability with increased energy savings by using less computer hardware and therefore less electricity. Increased availability with the ability to snapshot virtual machines, clone virtual machines, and run redundant virtual machines. And increased security by isolating virtual machines from one another and isolating them from the core system, as well as isolating applications and the ability to run legacy applications that wouldn't be possible sometimes on a regular company computer.
What he said there that's critical is the allowing you to run different operating systems, and when you allowing you to even run some legacy. I mentioned that in my software class a couple days ago. If you have a application, maybe you have an old game. I play a game called Diablo, and Diablo was not made, the first Diablo was not made for Windows 11. It was made for probably Windows XP, although it might be Windows 7. I don't remember. But it has problems. If I were to try to run that program on a new computer with the newest operating system, it would have problems. But it wouldn't have a problem if I create a VM, a virtual environment with an operating system that's the operating system that was available when Windows, when Diablo 1 came out way back in the day. All right. So that's enough about virtualization. Really, the chapter only mentions the fact that virtualization has to be supported by both the CPU and the hardware, the rest of the hardware that your computer has. It's really all they talk about, but I wanted to give you a little bit more than just that blurb. So the next thing they talk about is all of the slots that you have on a computer. So you have PCI and AGP and PCIe slots, and other slots as well. Now, peripheral components connect to the PC. You take a video card, and I don't have one handy. They're all in my equipment, and you slide it into this slot. Or a sound card, or let's say you want to add some USB 3 slots to your computer. Your computer only has two USB C. It doesn't have any USB C. It only has USB 3, and you want to add USB C capability to your computer. Well, you would buy a card that would connect to one of these ports. Specifically probably this port, unless you buy a PCIe port that would connect here. You can tell it's PCIe because it has this little lever at the end. The other cards don't. This is probably a 16. If I look closely at it, this is probably a 16, and that's probably a 2, and this is maybe an 8. They come in 2. I think it's 2, 8, and 16 when we're talking about PCIe slots. It's the newest technology. They also have an AGP expansion slot. You need to know that AGP is a type of video port, and you might see it out there in production, but it's really older technology. And if you're seeing an AGP card, you're probably seeing a computer that probably needs to be upgraded. You can see here they also have a serial port. We generally don't have serial port, and USB 2.0, or it might even be USB 1.0 slot. So it's a really old computer that has an AGP expansion port, but you need to be aware of it because Windows 7 ran on these type of computers. And you have to be aware of it for the exam that you're going to take. Here I already talked about this. It's X1, X2, X4, X6, 8, 16, and 32. It's the number of buses, and that just makes sense because as you look at it, this PCIe times 1 has far less. Probably has 8. I'm not sure how many. It doesn't have one bus, I promise you, but it has fewer buses than the 4, 8, or 16. Your motherboard has the capability of running multiple PCIe 16 or 32. One of my motherboards, if I installed I cannot install 4 PCIe items in my computer. I can only install 3, even though there are 4 slots. It just has a maximum of 3. Another of my motherboards had a little bit older. It had that 4th slot. I could either have an M2 or I could have an X16. I couldn't have both. Maybe it was a X32, I don't remember. But the point is I had to pick, do I want an M2 chip? That's an SSD that connects directly on the motherboard, or do I want to use that video card? It's not just for video cards. PCIe is for any kind of adapter. So conceivably, today's motherboards that you buy have only PCIe slots, and when you go to buy a peripheral to add to the computer, like USB-C, adding USB-C to the computer, it would actually be a PCIe 1 slot on one side. They kind of show you in this picture how it slides into the slot, and the number of buses determine the thing. So here's a × 1 and here's a ×8. So I guess maybe a ×1 is only two, an IO, a single IO for send and receive would be on two different lanes, and then an 8. All right, then I take back my promise that I gave you earlier. The next one is just one receive and send, and an 8 has 8 lanes, a 16 has 16 lanes, and a 32 has 32 lanes. That just makes sense, doesn't it? Right? All right. So anyways, that's the presentation for today. Again, the book we're using is The Complete A+ Guide to IT Hardware and Software by Professor Cheryl A. Smith. This is for the A+, CompTIA A+ 2020, 2020, 1001 and 2020, 1002 exams, the hardware and software exams. You can pick this book up inexpensively if you don't have it, to have a hard copy, or you can buy the UCertify copy if you want. I think it's 160, but my students have told me there's ways to get it for less than that if you look around for a coupon or something. It was 120 at the lowest price. But if you're getting ready for your A+ certification, having UCertify is an ideal way to prep. Along with my videos, you'll be ready to take those A+ certification exams. You have to pass both. You have to pass the A+ hardware, and you have to pass the A+ software to earn the A+ certification exam. All right. So that is the end of my presentation. Let me go ahead and close the PowerPoint. Hopefully that was helpful for your learning process heading towards your A+ certification. Now, the textbook, however you access the material, is extremely useful to help you get the details. So, for example, the different layouts of motherboards. I would start making flashcards, either the old traditional way with 5x7 cards, or 8x10, no, not 8x10, 3x5 cards, or 5x7 cards. And one side put the size of the motherboard, on the other side put the capabilities, and then mix those up. And then when you're studying, when you have a time, instead of playing on Facebook, just go through those cards forward and backwards, right? And see if you can answer those questions. It's an excellent way to prepare for the exam. You don't want to wait until you've finished all of my students. You don't want to wait until you finish all 15 weeks to get started making your flashcards. You want to make those flashcards at the beginning of the semester. As you move through the course, make your flashcards, so that at the end, when you're just adding to a stack, instead of seeing 15 weeks of content, an entire book, trying to figure out what the best parts are. So you can also digitally create flashcards. There's plenty of tools online, including PowerPoint, that you can make digital flashcards, and again, just build those as you go, and then practice them. And as you actually learn the material, you can set the cards that you get right every single time. As your stack grows, you can set those cards aside, and then maybe only go through those cards once a week, and then go through the cards that you're struggling with the material. Like when we get to RAM, you need to know the pin layouts on DDR DDR2, DDR3, DDR4, DDR5, for example. Well, DDR5 is, I don't think it's out yet, but DDR5 in graphics cards, but DDR5 is, oh yeah, DDR5 is out. You have to know how many pins are on each one of those. And there's just not something that you learn long term. I could not tell you right now the pin layout on a DDR4 card. I can't. I know what it looks like. I know what it fits in. I know how to make sure it's compatible. But to tell you how many pins there are, I knew when I took the exam, and the question was on the exam. But the only way to get ready for that is to make some flashcards or some other study note to make sure that you're reviewing that content over and over again until you know what they are. And then later, you can forget it. And then when you're helping a client, you just need to know how many that you're ordering the right RAM size for the motherboard that your client has. All right. Okay, so it's been a pleasure helping you today. Hopefully it was helpful for you. My name is Don LaFont, Professor Don. If you're watching this with me now, hang on. We've got a minute, and I'm going to, in a minute, I'll give you an opportunity to ask questions. If you're watching this as a recording and you're taking the class with me live, ask your questions inside of the help discussion forums. If you are asking, if you're just watching my video out on YouTube, thank you, first of all, for watching my video. I appreciate that. If you enjoyed it, give me a thumbs up and like and subscribe. And if you you might as well go ahead and hit the bell to be notified when I release new videos, especially if you're taking it in the summer of 2022. I'll be releasing these videos once a week for the next 13 weeks as we get through the content, and you'll be notified when the next video is released. I plan on continuing to release videos on other topics, including Cisco 1, 2 are already out there. Cisco 3 is coming after I get done with these 8+ certification videos. But if you click on announce, then you'll be notified when the videos are released. Anyways, thank you for coming to class. That's all I've got for you. Again, enjoy your day, and I hope your learning goes smoothly and you have fun exploring, especially if you're building a computer. That's even more fun. Anyways,